Right guys, this is Mintomath stage 5. It's good news, we got fractions on this one. So kicking it off with multiplying fractions. Probably the easiest thing actually you can do with fractions. When you're multiplying fractions, we've got 1/5 multiplied by 1/2. So when multiplying, it's numerator times numerator, so it's 1 times 1. And denominator times denominator, so you multiply straight across, and my answer is 1 over 5 times 2 is 10. When you do multiply across and end up with an answer, you should always look to simplify it. I can't simplify this, so this is my final answer, 1 over 10. And we'll come back to that again actually later on once we are dividing fractions. B, adding fractions. When you're adding fractions, we want the denominators to be the same. So we'll see in this case, both denominators are 7, so we can add them straight away. 1/7 plus 4/7 is 5/7. Most common mistake here people make is they add the 7s as well. You don't need to do that. You've got 1/7, you've got 4 more over here, so it is 5/7 altogether. Subtraction acts in the same way. We need to have the same denominators. Luckily, we do. In this case, we got 9s as the denominator. So 4 9s, take away 2 of those 9s, and we end up with 2 9s. Now D, we're dividing fractions. When we're dividing fractions, you've got the hint up here. It is keep, change, flip. So KCF. We're going to keep the first fraction, change division to multiplication, its inverse, and we flip this. We find its reciprocal. And after that, it's a case of multiplying straight across like we did in question A. So, in this case, we have got 1/9 divided by 1/5. Keep the first fraction, I change division to multiplication, and I flip the final fraction, so it becomes 5 over 1. And now it's simply a case of multiplying straight across. 5 times 1 and 9 times 1. So my answer is 5 over 9, and again nothing divides into 5 and 9 at the same time. So 5 over 9 is my answer for this one. This is where we get a little bit more complicated. We've got some mixed numbers. In order to work with these mixed numbers, we'll need to change them into improper fractions first. So our step 1, when we have 1 and 1 over 3 divided by 1 and 3/4, is to change them into improper fractions. So we need to figure out how many thirds are in one whole number. So we need to do 1 times 3, and then we add on an extra 1. So that's going to be my numerator, and we're working in thirds. Same with the second mixed number. This time we're going to do how many quarters go into 1. So we'll do 1 times 4 plus 3, and that's over 4. So our improper fractions are 4 over 3 divided by 7 over 4. Now it's a lot easier to work with. This comes back to our keep, change, flip, and that's our second step. So it is 4 over 3 multiplied, because remember we're changing division to multiplication, and we flip the final fraction, so it becomes 4 over 7. And again, when we're multiplying, we multiply straight across. So it is 4 times 4 over 3 times 7. And our answer becomes 16 over 21. Again, I don't think I can simplify this. 2 doesn't divide into both of them. Neither does 3. Neither does 5. Neither does 7. So it looks like this is fully simplified. We can't do any more with it. So the 16 over 21 is our final answer on this one. With f, we don't necessarily have to change these into improper fractions, but I will do actually, and I will do because I can see that at the moment I could take these away straight away and it'd be absolutely fine, because this fraction here, 3/4, is still bigger than a half. But if this second fraction here had been bigger than the first fraction, then I would definitely have to change them into improper fractions first. So I will change them into improper fractions so that you know how to do it. So it is 3 3/4, and I'm taking away from that 1 1/2. So step 1, as we did in the previous question, change them into improper fractions. So it's going to be 4 multiplied by 3. That'll be 12, we know. But that tells me how many quarters are in 3 whole numbers. Plus another 3/4. I'm taking away from that 1 times 2 plus 1 over 2. So I've got 15 quarters. Take away 3 halves. And step 2 will be to actually do this. It's good that we got this one actually, because we haven't had this previously. If you remember previously, we need to have the same denominators when we're subtracting. If we don't, we're going to have to change them. We're going to have to change one or both of them. So we want the LCM of 4 and 2. So what's in the 2 times tables but is also on the 4 times tables? That's nice and easy. We've got a 4. 4 is in both times tables. We only time the first one by 1, so we do the same to the top. On the second fraction, to get from 2 to 4, we have to times it by 2. And whatever we do to the bottom, we do exactly the same to the top. So it's 3 times 2 is 6. And now we've changed them. 3 over 2 is exactly the same as 6 over 4. They're equivalent fractions. So we've changed those denominators. Lastly, let's subtract them. So it's going to be numerators subtracted from each other to see how many quarters we have. 15 take away 6 is 9 over 4. But at the moment it's top heavy, it's an improper fraction, so our last step is always change it back into a mixed number. This is 9 divided by 4. So how many 4s go into 9? 2 of them go in, and there's 1 left over. So 2 times 4 takes me to 8. So we got a quarter left over. So that's what it looks like as a mixed number. 2 and 1/4. So there was a lot to that question. Change them into improper fractions first, then changing the denominators before we do our subtraction, and converting them back into mixed numbers from improper. So 2 and 1/4 for that one. On the next one, again, going to have to change these into improper fractions. So we have got 1 and 1/5 multiplied by 1 and 5/6. Change them into improper fractions. We've got 1 times 5 plus another 1, and we're multiplying that by 1 times 6. So it's always that big number here, that whole number multiplied by the denominator, and we add on 5. In our first fraction we have got 6/5 multiplied by 11 sixths. Again, easiest thing with fractions, I think, multiplying them, because we just need to multiply straight across. So this becomes 66 over 5 times 6 is 30. But again, we're left with an improper fraction, so we need to change it into a mixed number. 66 divided by 30, so we're looking for how many 30 is going to 66. Well, that's 2 of them. There are 6 left over, so it's 2 and 6 30ths. But this 6 30ths can be simplified. So we still have 2 whole numbers, but I can divide 6 into 6, and I can also divide 6 into 30. 6 into 6 goes once. 6 into 30 goes 5 times. So the answer to this, fully simplified, is actually 2 1/5. And that is how you multiply mixed numbers. Lastly, addition with improper fractions. On this one, we can again change them into improper fractions and work from there as we did with the subtraction, making sure you change the denominators and so on. I'm going to do it the quicker way on this one, just so you see both methods. So we've got 3 3/5 plus 1 3/4. So what I'm going to do is I'm going to treat these separately. I'm going to keep the whole numbers together. So 3 plus 1, and obviously that's going to be a 4 eventually. And now I'm going to work with the fractions separately. So it's going to be 3/5 plus 3/4. Nothing unusual on this. Again, we're looking at denominators. Because it's addition, the denominators need to be the same. So I'm going to have to change these. So I'm looking at the 5 times tables, the 4 times tables, what appears in both. 20 is in both times tables. So I'm going to change them both to 20s. To go from 5 to 20, I multiplied by 4. To go from 4 to 20, I multiplied by 5. And when you are changing denominators, you're always looking to multiply, nothing else. So you're multiplying it by something to change it into something else. As before, whatever you do to the bottom, you do exactly the same to the top. So it needs to be 3 times 4 is 12. 3 times 5 is 15. And again, 3/4 is equivalent to 15 over 20. They are exactly the same fraction. And 3/5 is equivalent to 12/20. Lastly, adding them together, we get 27 over 20, which is actually, again, we don't want top heavy fractions, it's actually 1 7/20. But obviously that can't be the answer to 3 3/5 plus 1 3/4. It must be a bit bigger. If you remember earlier, we added the whole number separately and we got this 4. So this 4 needs to be added back onto it now. And that's giving me a final answer of 5 7/20. So there's a couple of bits to that answer. Separating them out just made the numbers a little bit easier for yourself. We could have changed these into improper fractions, like I did previously, but you'd have bigger numbers. So we're just looking to make it as easy as possible for ourselves. So 5 7/20, and that is everything you need on fractions.